The revolution in information and communication technology in recent years has created the need for adequate security measures that guarantee effective protection in terms of communication and user rights. In this field, researchers at the Universitat Politècnica de València have developed a new quantum key distribution technique for secure communication.
This patent actually is focused on a novel technique which is called differential phase shift keying, but it's on the frequency domain, which is not the typical approach, since a typical one is based on the time domain DPSK, and it brings several advantages. In particular, the fact that one can use integrated components to achieve the necessary interference upon which the technique is based, and that implies much more stability and much more compact design.
The patented technology can be found within the framework of communication systems, and more precisely in quantum key distribution or quantum cryptography. The study developed by researchers at the UPV is of particular interest for communication security in banking applications, the transmission of election or voting results, or electronic signatures, as well as for military and aerospace applications.
The patent addresses a specific target now, which is all those areas in which the security of communications is a sensitive issue. Okay, and that includes, for example, banking transactions. It also includes the possibility of controlling polling stations and electoral processes, and finally, defense and security applications. Notwithstanding, if we are actually able to adapt the technique in order to reduce the costs, that could be extended to ordinary communications.
Its characteristics allow it to be more robust, use less complex equipment, and have a higher quantum key transfer rate.
The main technical advantages come from the fact that interference, which is the technique which is the basis of the construction and the encoding and the decoding of the key, is based on a frequency domain rather than time domain approaches.
The project team is currently working on a conceptual testing of the technology, whose results demonstrate the viability of the technique through the development of an experimental prototype.